Here's a problem of three strings that are configured together to hold up a mass of 10 kilograms. T1 is suspended from the ceiling and is connected to a ring. The angle between that string and the horizontal is 45 degrees. T2 is 30 degrees above horizontal, and T3 hangs straight down and holds the mass. So let's use our free body diagram and look at the mass. Identify all the forces acting on the mass. The weight down is equal to the mass times gravity, or 98 newtons. I also have T3 upwards, okay, and the object is still. So how's this work out? Well, what we'll say is F net in the y direction equals MAY. So the forces are T3 up minus W equals 0. Now why is it 0? The mass is not accelerating, it's not going anywhere. So T3 equals the weight, which equals 98 newtons. So that's a pretty common sense solution. What we want to focus on is using this formal methodology of using Newton's second law in the y direction to figure out what's going on in the wires. Let's come back here and analyze what's happening to the ring and find out if by doing that we can find out what T1 and T2 are. So in this situation I have T2 over here and T1 over here. I'm going to break these vectors down into their components. So I'll draw those in blue. T2x, T2y, T1y, and T1x. So by breaking them down in components, now everything's on x and y axis. I actually want to cross out the original T1s and T2s so I don't double count them. Let's use Newton's law here in the x direction. And the forces in the x direction are plus T2x minus T1x equals 0. Okay? So what that means is that T2x equals T1x. So now we know that they're equal and opposite, which means the ring will not move side to side. So that's one conclusion. In the y direction, we have the forces in the y direction equals MAY. So that's T1y plus T2y minus W equals 0. Now, if we remember our formula, T1y is T1 times the sine 45. T2 is the sine of 30. That equals 98 newtons. So, excuse me, have an expression for finding T1 and T2. So here's one equation with two unknowns. Here's the other equation with two unknowns. Let's take this one on the left a little further. In the x direction, T2 cosine of 30 degrees equals T1 cosine of 45 degrees. These are the formula for the components. If you actually solve this, you can find out the relationship between T1 and T2. and the value is 1.22 times T2. Okay. Now we can use this equation for T1 in the equation on our right here and substitute. So this becomes 1.22 T1 times the cosine of 45 is 0.707 plus the sine of 30 is 0.5. All that equals 98 newtons. Okay, when I solve this I actually get, sorry, my mistake over here is T2. So I've got one equation with just T2 in it, and when I solve I get T2 is equal to 72 newtons. T1 is 1.22 times that, or 88 newtons. What happens then, this is, over here in green we'll put the values. This is 72 newtons, 88 newtons. So what are the values of the components? Well, the T2x is 62.3 newtons. T1x is 62.2. So, with round-off error, we see those are balanced. T1 in the y direction is 62 newtons, and T2 in the y direction is 36 newtons. So those actually add up to 98, and 98 is the weight and therefore the tension in T3. So no matter what's going on, we can resolve this by breaking forces down into their components, adding up everything in the x and everything in the y direction using Newton's second law, and then combining those results to find the answers.